Seasonality of Kawasaki disease is similar to chickenpox, erythema infectiosum, and pharyngo-conjunctival fever in Japan. The seasonality of incidence of Kawasaki disease is bimodal, with peaks in June and January. We examined whether or not this bimodal seasonality is unique to Kawasaki disease. The monthly reported number of cases of Kawasaki disease and that of pediatric infectious diseases between 2000 and 2010 were obtained from Japan's nationwide surveillance of Kawasaki disease and the Centenary Report of National Institute of Infectious Diseases, respectively. The monthly number of cases was adjusted to the length of month. For each month of the year, M is 1 to 12, we counted how many times the monthly number of cases increased or decreased from the previous month. We used the time series of 2001 to 2010 because January of 2000 does not have the previous month. The maximum count of increase is 10. For statistical inference to identify a peak within the dataset, we assumed a null hypothesis that an increase or decrease are random in each month of the year. We employed Jacob-Benoist's binomial distribution, which is expressed in the following equation. In our case, increase and decrease are random, or in other words, a coin toss. Therefore, the p is 0.5. The n value represents the number of trials of a coin toss. The n is 10 in our case. The k value stands for the number of times at which the monthly cases increase from the previous month. Figure 1 shows Jacob-Benoist's binomial probability and its cumulative probability. The cumulative probability of recording 9 or 10 increases during the 10-year records is 0.00107. This very small probability rejects our null hypothesis. In other words, the increases in this month in a year are not by chance, but are significantly consistent. We defined increases in 6 to 8 years as a non-consistent increase. Similarly, we define decreases in 9 or 10 years as a consistent decrease, and decreases in 6 to 8 years as a non-consistent decrease. We introduced the term sequence of increase, or SOI, which indicates a sequence of months with consistent and or non-consistent increase. Similarly, we introduced the term sequence of decrease, or SOD. The peak is defined as the shift from a sequence of increase to a sequence of decrease, under condition that the SOI contains at least 1 month of consistent increase, or SOD contains at least 1 month of consistent decrease. Kawasaki disease, chickenpox, erythema infectiosum, and pharyngo-conjunctival fever share a similar bimodal seasonality. The peaks for these 4 diseases occurred from June to July and December to January. Interestingly, Group A Streptococcus pharyngitis presented a trimodal seasonality. The troughs of Group A Streptococcus were in August, January, and April, which followed the holidays of schools and preschools. This finding suggests that these troughs were due to the separation of children during the holidays. The example of Group A Streptococcus suggested that the school term may be an important determinant of the seasonality of pediatric infection. Possibly this is because pediatric infections are transmitted between children through direct contact, coughs, or feces. The bimodal seasonality of Kawasaki disease was shared by chickenpox, erythema infectiosum, and pharyngo-conjunctival fever. This finding suggests that Kawasaki disease is also transmitted through a route shared by these 3 diseases. We are grateful to Professor Yoshikazu Nakamura and Dr. Mayumi Yashiro of Jichi Medical University. Thank you very much.